Hi, class. What I hope you noticed with your bell work was that this problem, when I added 10,000 plus 100, I accidentally added the places that were not the same place value. Normally, when we do an addition problem, we like to take the place values and line them up together so that I add the ones place with the ones place, the tens place with the tens place, hundreds place with the hundreds place, and so on. When you have everything out of place, you can tell we're going to get the wrong answer. Okay, so with addition, we know we should get everything in place, and then add all of our places together. So what does this look like when we're dealing with scientific notation? Okay, 10,000 is the same thing as 1 times 10 to the fourth. 100 is the same thing as 1 times 10 squared. We already know that the 1 in both of these numbers is not in the same place value. So we can't do the same thing we did when we were multiplying and just put these two together. First, we have to line up the place values so that they are in the correct place. That means, as we take a look at these powers of 10, to line up the place values, these two need to be the same. Okay, now we're going to come on down here to our notes, and we're going to find where it says that with the star. We're going to give it a nice big circle or color in the star so that you know this is the big difference between adding and multiplying. In order to get the place values to line up, the exponents have to be exactly the same. Okay? Now in our first example, we are in luck. Okay, so we're going to take our example from right here, and we're going to do it in this box together. Okay, in our first example, we have both of these that are raised to the negative 8th power. So if these are both the same, that means all of our place values are lined up, okay, with the decimal. So now we can move on to our next step, which says that we can go ahead and add or subtract the coefficients, right? Remember, that's our vocabulary word, and it means the first number or the first part of scientific notation. So here we go. We're going to go ahead and do that first step. Because these are lined up, I can add 6.5 plus 3.99. Now watch as I make sure to line up the decimals together, or just make sure you're double checking yourself in your calculator. But be very careful as we're adding place values. Notice I put a 0 right there just to hold that place. Now we can add. 0 plus 9 is 9. 5 plus 9 is 14. Carry the 1. Bring down my decimal. 6 plus 1 is 7. Plus 3 is 10. There, we have the first part of our answer in scientific notation. Now we're ready for step 3. Keep the exponents the same. Wait, I don't add them or subtract them or multiply them or anything? I just bring down the exact same exponent as negative 8? That sounds weird. Well, that's because we're bringing down place values. Okay, let's go back to our bell work and look at that one. When we add 10,000 plus 100, we brought down these place value zeros. We didn't get any more place values by adding 100. We didn't get any less place values by adding 100. So adding is different than multiplying in that way. Okay, so we're going to remember, very important on number 3, this is different. We are going to keep the exponents the same. However, we do have one very big thing that we need to look at the end of our answer. This answer is correct. However, it's not true scientific notation. Just like last time, if we get too many decimal places in front of the decimal, we have to fix it using our good old trick. Now I'm going to write the trick off to the corner just to have some room. Remember Dr. Lars? This helps us remember if we move to the left, we're going to add. If we move the decimal to the right, we are going to subtract from the exponent. That helps us as we are shifting things to get our decimals and our exponents correct. Okay, back to the problem. So as I shift to the left, to right there, I need to add 1 to the exponent. -8 plus 1 is -7 because we're dealing with negatives. Now I'm done. Okay, that was a lot of information. Let's try it again with our second example and see how we're feeling. Okay? Our second example says we're going to have 7 times 10 to the 4th. We are subtracting this time, minus 2.07 times 10 to the 3rd. Uh-oh. Our first rule, we have to make sure that the exponents are the same before we start adding or subtracting. Now, because it's me, I always like to take the smallest exponent and make it bigger to match the bigger exponent. Could we go the other way? We sure could. But I like this way easier because I think it's easier. Okay, so what I'm going to do is I'm going to take this number right here and I'm going to use Dr. Lars to help me make this into 10 to the 4th power so that it matches. Now, if I want to add 1, I need to take this decimal to the left 1 time. Okay, 0.207. There. Now I'm ready. Bring on down the rest of the problem. Now I have 2 powers that are the same. And when they're the same, I can start adding together. Okay, so I'm going to take a look at adding or subtracting the first numbers, the coefficients. That's the 7 and the 0.207. Now, because I can, let's use a calculator for this part. 7, minus, I almost added, but this is a subtraction problem. 0.207 equals, I got 6.793. And because our exponents were the same and they're just marking place values, I bring it on down and keep it exactly the same, 10 to the 4th. Now I need to check my answer and make sure that I only have 1 number to the left of my decimal. I do, so I'm done. This is exactly how it needs to be. All right, we've done 2 examples where you watched me. Now let's attempt the first one together. What I'd like you to do is look at this example right here. We are adding, okay? Exponents are an 8 and a 9, so they need to be fixed. I'd like you to pause and try this one on your own, and we'll check your answers in a minute. Go. Okay, hopefully what you noticed is that in order to fix your exponents, you would either need to add one to this side or subtract one to this side. Either way is fine, as long as they're the same. I'm going to add 1 to this side to make both of these 10 to the 9th power. Because I added, that means my decimal moved 1 to the left. So my new coefficient, my new first number, is 0.615 times 10 to the 9th. Now these are the same, and I'm ready to add. So as I'm adding, I'm going to take the front numbers together. So I'm going to do 0.615 plus 2.9, and I get 3.515. There, I've added the first numbers together. My last step tells me to keep the exponents the same, so I'm just going to bring down that 10 to the 9th and check my answer to make sure it's in scientific notation. Yep, it sure is. Okay, let's do one more together to check for understanding. Let's do a subtraction problem. And good luck for you. These exponents are already the same, so you get to work from there. Go. Okay, hopefully you were able to subtract these. Okay, so we're going to subtract from left to right. Remember that order does matter when you're dealing with subtraction. All right, so when I subtracted my coefficients, my front numbers, I got 2.95. Then I need to keep my exponents the same, just bring it down, 10 to the 10th power. Excellent. All right, that one was so easy. I feel like we should do one more together. Okay, so let's check. Actually, you know what? I think you've got this. Now I'm going to let you work and make sure to ask your teachers and get your answers checked as you go. Good luck and have a great day.